In this video, we want to look at an example, crawling babies. The following data represent the age in weeks at which babies first crawl based on a survey of 12 mothers conducted by Essential Baby. So we have 12 different ages at which a baby first crawls. We got 3 parts to this question. A, draw a normal probability plot to determine if it is reasonable to conclude the data come from a population that's normally distributed. B, draw a box plot to check for outliers. C, construct and interpret a 95% confidence interval for the mean age at which a baby first crawls. So in this particular case, because we have a small sample of data, we only have a sample size of 12, then we have to know that the data comes from a normal distribution in order to be able to use the t-distribution to construct a confidence interval. We also have to know that we don't have any outliers. So we have to check part A and part B in order to be able to do part C. We're checking our conditions to be able to do this. Now again, if we had a sample size of 30 or larger, we wouldn't have to worry so much about part A and part B. But because we have a small sample, we must check this. Now because we're having to do a probability plot, I'm going to do this problem just in StatCrunch. So in StatCrunch, I have already entered the data into this far left column, and I have labeled that column age in weeks. Again, this is representing the age at which a baby first crawls for 12 randomly selected babies. Now, in part A, we're supposed to construct a normal probability plot. Again, in StatCrunch, we don't really have a normal probability plot. We have a QQ plot, which is the same idea. And so we're going to do that instead. So I go to Graph, and I'm going to go to QQ plot. I select the column that has the data, which is this age in weeks column. I want to compute the correlation statistic, and I want the quantiles on the y-axis. So I'm putting check marks in both of those boxes, and I'm going to select Compute. So I get my graph, which is shown here. That data does look somewhat linear, although there's a little bit of curve to it. But notice that our correlation statistic is 0.982. That's the important thing. So our correlation statistic is 0.982. If I compare that to our critical value that I'm going to look up in Table 6, which is page A13 of the appendix of your book. Now we have a sample size of 12, and so our critical value is 0.928. So our critical value is 0.928 because our correlation statistic 0.982 is larger than this critical value. That means that this data could come from a population that's normally distributed. So question A, our QQ plot. Again, we used a QQ plot technically instead of a normal probability plot, but it does seem reasonable that our data, our 12 data values, are coming from a population that's normally distributed. So the answer to A, yep, it looks like the data are coming from a normal population. Now we also have to create a box plot to make sure that we don't have any outliers. So I'm going to go back to Graph, and I'm going to select Box Plot. Again, select the name of the column that has the data. I'm going to use fences to identify outliers. That's selected by default. And I like to draw my box plot horizontally rather than vertically. So I'm going to say Compute. Here is our box plot. And so there are no outliers illustrated in that box plot. So we do not have any outliers. So we're going to be able to construct our 95% confidence interval because our data is coming from a population that's normally distributed and we don't have any outliers present. So now I can go back and actually construct the confidence interval. I'm going to go to Stat, and t-stats, one sample. We have data. I'm going to select the name of the column that has the data. I'm going to do a confidence interval, and our level of confidence is 95% level of confidence, so that's there by default. Otherwise, I would enter it and say compute. So our lower limit is 31.90 if I round to two places, and the upper limit is 44.60 if I round to two places. So our 95% confidence interval is 31.90 to 44.60. So there's our confidence interval. So what does this mean? We are 95% confident that the true mean age at which babies first crawl is somewhere between 31.90 weeks and 44.60 weeks. So that's the interpretation. We are 95% confident that the true mean age at which babies first crawl is somewhere between 31.90 weeks and 44.60 weeks.